Hi, good morning, Algebra 2. I am sorry I'm not here today. I just not feeling well, so I stayed home. But I went ahead and made this video for you. So we're going to go through lesson 11. So I'd like everyone to turn to page 58. So go ahead and turn to page 58. There we go. We're going to look at sequence as a sum of their terms. But first, what I want you to do is if you're looking at the top of 58, I'd like you to evaluate these mentally. So first, I'd like you to do 1/2 plus 1/4. Evaluate that mentally. That means without a calculator. So go ahead and hit pause and then finish all of these questions. Okay, so hopefully you got the same answers as me. When you're adding and subtracting fractions, you have to have common denominators. So that is what I did really quick. Again, I did all of this in my head because it says to evaluate mentally. So there was a pattern that I picked up on. So 1/2 plus 1/4 equaled 3/4. 1/2 plus 1/4 plus 1/8 equaled 7/8. 1/2 plus 1/4 plus 1/8 plus 1/16 equaled 15/16. But 3/2 plus 3/4 plus 3/8 plus 3/16 equaled 45/16. Okay, so now what I would like you to do is at the bottom of your paper, we are going to be looking at this paper trail. So Tyler has a piece of paper and is sharing it with Alina, Claire, and Andre. He cuts the paper to create 4 equal pieces, then hands one of piece each to the others and keeps one for himself. What fraction of the original piece of paper does each person have? So go ahead and answer that question, hit pause and answer that question. Okay, so, whoops, let's go back. You should have gotten that if we cut a piece of paper into 4 equal pieces, that everybody gets 1/4 of that paper because he's cut it into quarters. All right, so Tyler then takes the remaining paper and does it again. He cuts the paper to create 4 equal pieces, then hands each person each piece to each the others and keeps them for himself. What fraction of the original piece of paper does he have now? So, or does each person have now? So go ahead and hit pause and answer that question. Okay, so if Tyler takes that remaining piece of paper and he cuts that into fourths, a fourth of 1/4 is when we say of, so 1/4 of means multiplication of 1/4 means that Tyler has 1/16 of the paper, but everybody else still had 1/4, so everyone has 1/4 plus 1/16. We have to create we have to create common denominators. So to do that, we get, let's see if I can get this to work, 1, so 4/16 plus 1/16, and we get 5/16 of the paper. Okay, so now the last question. Tyler then takes his remaining paper and does it again. What fraction of the original piece of paper does each person have now, and what happens after more steps of the same process? So go ahead and hit pause and answer that question. Okay, so Tyler took, let's see, he took 1/16 and he took 1/4 of that, so we have to multiply that, and we get 1 over 4 times 16 is 64. Oops, there it is. 1 over 64. So that's what Tyler has left. And then we can take the 5/16 and we can add the 1/64 because that's what he gave everyone. And again, we have to create common denominators. So that's going to be, we need to multiply this one by 4. So we get 20 over 64 plus 1 over 64. And we get 21 over 64 for everybody else. Okay, so go ahead and turn the paper. And now we're looking at this threefold design. This is where the real learning is going to take place. So this is a geometric shape built in steps. The first step, step 0, is an equilateral triangle. So we start with an equilateral triangle. Then to go from step 0 to step 1, we take every edge of step 0 and replace its middle third with an outward facing equilateral triangle. So right here. So this is This is step 0 right here. Here, I can highlight step 0 again. This is all in your packet. We're on page, what page is this? 59. So this is step 0 right here in purple. Okay, that's step 0. Right here is where they did step 1. To go from step 1 to step 2, we take every edge of step 1 and replace its middle third with an outward facing equilateral triangle. This process can continue to create any step of the design. What I'd like you to do is answer the question, so go ahead and draw what you need to draw, but I'd like you to find an equation to represent the function s, where s of n is the number of sides in step n, and what is going to be s of 2. Consider the different function t, where t of n is the number of new triangles added when drawing the step n. Let t of 0 equal 1. And then how many new triangles are there in steps 1, 2, and 3? And explain how you know. And then what is the total number of triangles used in building step 3? So hit pause and then work with the people at your table. You do not need to do this alone. Okay, so I got that s of 2 was equal to 48 because I found the recursive that s of 0 was equal to 3. So then I could find s of n, which is 4 times of s of n minus 1 for all n's greater than or equal to 1. And I also was able to find a explicit, or this is the non-recursive, or the nth term was another way that we could say that s of n was equal to 3 times 4 to the n. Again, I plugged it in and I checked my work and it worked. So now what I want you to do is make sure you answer number 3. So go ahead. I'm sorry, number 2. Consider the different function t, where t of n is the number of triangles. Okay? Adding new triangles step n. Let t of n, t of 0 equal 1. How many new triangles are there in steps 1, 2, and 3? And explain how you know. Okay, for this one I created a table. So the number of triangles in the step is the same as the number of sides in the step n minus 1, because each segment generates a new triangle. So I created a table to help me figure it out. I kind of had to draw and count some numbers, but hopefully that is what you got as well. If not, write yourself some questions and you can ask me about it on Friday. Okay, now what I would like you to do is answer what is the total number of triangles used in building step 3. So go ahead and hit pause so that you can answer that question. Okay, so hopefully you saw that in step 2, or I'm sorry, question 2, we had already solved for 3, and then it was right here. Let's see if I can get my little pointer. Right there. Okay, so now, let's see, I think my, move this. Okay, so what I want you to do, this I don't believe is in your packet. It is not. Okay, so maybe on a separate piece of paper, I would like you to tell me what it would mean to find the sum of a sequence to find that f of 0 is equal to 3/10, but f of n is equal to 1 over 10 times f of n minus 1 for every n greater than or equal to 1. So go ahead and hit pause, and I'd like you to do this on your desk or on a blank piece of paper on the back of your packet, whatever. So write this out and go ahead and do it. Okay, I did some work here, so go ahead and hit pause and look through what I did. I just did some multiplication and figured it out. I just found the first 4 numbers in this sequence. What would it mean to find the sum of these? Well, we would want to add all of these up. So we would do 3/10 plus 3 100ths plus 3 1,000ths plus 3 10,000ths, and I would like you all to tell me what that answer is. All right, go ahead and get that answer. I wrote down the sum. Sum means you're adding everything up. So right here, go ahead and add all of those up and give me those answers, and I'll look for that answer on Friday. All right, so in this unit, we said we can determine the sum of a sequence representing a situation. So this is half the homework. So Lynn spent 80 minutes doing homework on Monday. Each day from Tuesday through Friday, Lynn spent half as much time doing homework as the day before. How much total time did Lynn spend doing homework from Monday through Friday? Explain how you know. So go ahead and hit pause and answer those questions. Okay, so hopefully you got 155 minutes. Oops, let's go back. So you should have seen that 80 minutes for day 1, half of that is 40, half of that is 20, half of that is 10, half of that is 5, and if we add all of that up, if we take This is called the sum. The Greek letter for sum is the summation right there. So the sum is 80 plus 40 plus 20 plus 10 plus 5. That's how we get 155. Okay. At the bottom of page 60 is the lesson summary. So the sum of a sequence is the sum of its terms. Another way to say that is to add up all the terms in the sequence. So there is an example in your packet. It says, for example, suppose you were given $1 for the first day, $2 for the second day, $4 for the third day, and it doubled each day for 7 days. After that, after finding each term of the sequence, you can find the sum. So we got 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64, which is 127. All right, so go ahead and read through that. Your homework for tonight is page 61 through 63. That is the lesson 11 practice problems. So go ahead and work on all of those. If you have any time in class, that's what you should be working on. Otherwise, I will see you all tomorrow. Have a good night.